Hello and welcome back to Poor Man's Electronics Bench. Everybody would like to try to find the best capacitor replacement for an item that they're working on, and in this case I'm going to go through a couple of choices that I made. This is the power supply for the Sencore PA251 power adapter for the LC102. It's just a unregulated linear power supply. I covered it previously, and I've got a Funyan original 105 degree C capacitor on it. 4,000, I believe it's a 4,000 micro, no, 4,700 at 35. So my mission is going to be to remove this capacitor, and I'm also going to remove the leads off the transformer interface board for now. The main reason being is I'm going to extend them over to a breadboard so I can do some testing with components. And the obnoxious noise you hear in the background is my desoldering station I have running, so I'm going to try to remove the capacitor that I have in here. And I did put a small black mark on the board for the negative. It's curious to see that the board is marked for two different sizes of two different component footprints. In case somebody felt the need to go smaller, maybe there's another device that they had in plan for this. And then I did put a black mark on the negative. I'm going to reinforce that mark a little more so when I go to do the replacement I know for sure where my negative is. And then I'm going to, like I said, I'm going to remove this green with a yellow and a white wire, and then going to put some leads into this board and extend it over to a breadboard. I can do some test and measurement on it better. Come on, baby, you can do it. It's a lot of solder. There we go. Okay. I've got cleared out holes in it, guys, so my next part is going to be to extend that over to something I can put capacitors in and check the ripple on them with a load involved. I don't think anybody should ever have a capacitor video allowed without some testing involved, so that's what we're going to do. I'm going to go over testing capacitors with the original one, and then a couple candidates for replacement I'm going to have with a couple of different meters. First off, I'm going to use two easily obtained items from eBay or Amazon. I already lead zeroed the ESR meter. This one comes up with an ESR of 0.044, give or take, bouncing around a little bit. Well, gets down into the 2s or 3s if I get a little bit better contact. So seems to have a fairly good ESR. Although that doesn't charge anything up, I'm going to give it a quick discharge, and then I'll check it against the capacitor meter. I've got a 4230 about on a 4700. So the only thing I'm not doing currently is checking it for leakage right now. And I'm going to introduce the two contenders. The first one is a Cornell Doublier that I was going over the one order I made. It's kind of a reduced height profile compared to this one. The diameter is about exactly the same. Lead pitch is just a touch wider. But this one, either one could be held off the board a little bit and that could be corrected. So I've got this guy. This was a this was like a 135 degree rated capacitor at about 3,000 hours, I think. Then I decided to go ahead and make another purchase because I need another capacitor about this size for something anyways. I'm going to go with a Worth Electronic 4700 at 35. This one's a model ATUL. It's a 105 degree C rated capacitor. This one is rated for about 10,000 hours at that temperature. So it's rated for really good longevity. The ripple current rating, I think this one had a slightly better one, and I'm going to do a little investigating to see if that's going to make a difference in other things. But in the meantime, I'm going to go with this one. I'm believing that the negative is going to be in this terminal. Shorter lead. It's also the shorter lead on the Worth, which is marked there. So not exactly marked the greatest, but you have what we have. So each one of those capacitors is currently about $6 a piece. So it's got a that ESR, after a little lead wiggling to make a good contact, that went down to about the bottom end of, well, this is actually, let's see here, went down to about the bottom end of resolution on that meter. I'll check it against the Worth. The Worth, it actually is giving a little bit of a negative indication on the meter. It's just kind of weird. These meters drift a bit, I guess. And go check this one again. That was a little higher up on the positive side. Okay, we'll check them for value. This one comes up with a 4200, which is similar to the, even though it's rated at a 47. Comes up with a 42 on that one. And it comes up with a little lower. Well, the good thing is this guy was probably capable of still having a serviceable life on him. Didn't necessarily need to be replaced right away. Wasn't defective. Maybe when I get the LC102 back in service, I will check him for leakage. If I had a 35 volt source, I could do that, but I'm kind of lazy to do that right now. But I'm going to check this out with one more device I have just for the fun of it. For the auction site guy, I got the Leader LCR-740 LCR bridge. It's found it to be fairly accurate. It's definitely nowhere near automatic. It's a lot of tweaking to go through. It checks things with a bridge oscillator working at about 1 kilohertz. So if you're going to measure resistance or capacitance using the RCL method, it's got to be switched over to RCL, and that uses a reductance. It hooks things up to the bridge. Let's see if I can get this in camera just a little better. What I'm going to do is, again, this is a AC oscillator, so polarity really isn't as important. And first off, we're going to try checking for capacitance. So I'm going to go in the 1000 microfarad range for 1 unit. So that means when this display displays a 1.0 and it nulls out on the meter, that is a 1000 microfarad capacitor. So 9-volt battery powered, which is very nice. First thing you need to do is turn your power on and turn the sensitivity up to something. Then you have your DQ knob. You don't have to pay attention to the reading on this. You're just looking to get your best dip or valley in the null. And then as you go up in value on capacitance, that was set for inductance. Here we go. Capacitance. Okay, we're going to go for capacitance here. So you can get your best dip on the meter, which is about right there. And turn your sensitivity up a little more. And then this guy, I'm looking, it's going for about 3000. So as I get closer to 4, it's going down. And right now, it's giving me about the best dip about there, so I'm going to, you get your best indication when you keep on turning things up so the meter is as high as possible. So you got to go back to your DQ knob, adjust that. Whoops. I want to keep this guy up here. Got my best dip here, and then every time you change this a little bit, this guy's going to change a little. So as we get closer to here, you have to really be tweaking both controls. My sensitivity is up all the way now. I have my best dip about right there, and I have a display of about 4200 microfarads. So that's going to be about where we're going to sit. And the interesting thing about this meter is if you go to resistance, it is in actuality testing the equivalent series resistance by putting a 1000 hertz signal through it and then checking the internal resistance that way. So luckily we can just switch this over to the R range, and then this is going to stay at its lowest range of a 0.1, and turn your sensitivity up. And the resistance, the DQ knob does not have a function. So we're just going to look for our lowest value on the meter, our null, closest to the null, your value, your, there we go. Getting close, I'll turn my sensitivity up. That's about my best one. So right now this is telling me at 1000 hertz it has an ESR of about 0.48, which is actually a 0.048 ohms, because this is indicating a 1 on here would indicate 0.1 ohms. So keeping that in mind, what I'm going to do, instead of changing the meter around a lot, I'm just going to be, you know, the capacitance values are close on all these, so I'm just going to check the ESR in comparison with this meter. I made these leads up and they're slippery on the inside, and every time I go to squeeze them, the damn clip spins. There we go. Okay. So I've turned this guy back up, and this one has about very close to an identical ESR to point. The lowest reading I can get on the meter is about a 0.44. It's just slightly lower in ESR. The Cornell duplicate, and then this guy. really, they are all about the same. That point is about a .044. So really what that tells me is, although this guy is aged and I'm replacing him because of his age, I'm not going to think that this was in any way failing, but it is something to check. It's had a long and fruitful life and use, I'm sure, and like I said, that particular capacitor just take a beating of the ripple current all the time when that wall wart's plugged in, and something that you really don't want to subject the capacitor to and then hope that it's going to stay in service for you long term. If it has a failure, it can decide to spew its contents at any moment, and then you might have more issues on hand that you wanted. And here's a view of the CDE capacitor installed in place, and wasn't too hard to solder in, and the footprint on the leads was actually correct. I didn't have to do any modifications or anything, and just put a little note on there for the install date for any other person that might happen into this guy behind me, if it gets handed down to anybody else. So reassembly isn't terribly hard. I did tighten these guys up a bit. They're very secure right now, and I'm going to put a little bit of Loctite on here. There is a Loctite 290 thread locker wicking grade. This is green stuff. This is made to put on fasteners after they've been installed. This is also a very hard to remove locking compound. I can't imagine anybody would need to disassemble this. If they do, they're going to be cursing me up and down because of the fact that it's not going to come out easy. But I like using that stuff every now and then, mostly because it's got such a tenacious grab on things. I wouldn't recommend it for things like set screws on knobs. I usually use the blue stuff on that. But if it's for a mechanical connection that you want secured. So that's about it for reassembly on this guy. Just popping everybody back in here and making sure the cord grommets cords are all in really nice shape, and making sure the cord grommets are in there, and I just have to replace the screws. Not a big deal. This guy will happily be back into service in no time. Ready to power my LC102 through its next adventures. So I'm going to just finish this episode with this, and I hope that you enjoyed the content. If you like the content, please give me a thumbs up, and if you would like to see more content like this in the future, please feel free to subscribe, and you will be notified when the content is available. And thank you. And of course, we must have the capacitor testing autopsy porn, just to kind of qualify whether the old capacitor was bad or not. I'm going to compare it against the worth. I put that CDE cap in there. So I've got the unit set up for aluminum electrolytics. I set it for a value of 4,700 microfarads plus or minus 20% for a good bad qualifier, and a 35 volt leakage value. So I'm going to connect the old Fuyin capacitor. Well, I probably should lead zero myself again here. I'm going to lead zero. This is the BNC adapter to some short cords with a That's a 50 pico. I have that on there because that's a good buffer lead to throw on there for an LC53. This will calibrate. It's the equivalent of the low capacitance coax cable. It's on there, so it won't really hurt on the calibration at all. This unit's own leads are probably the actual factory leads that everybody loses are probably about the same value. And I'm going to do a short calibration as well. Those are both over and done with. So that should give a good ESR reading. So now I'm going to connect the Fuyin. Have to pay attention to the polarity in this one because we'll be doing voltage tests. So first thing we'll be doing is the value. 4250 plus or minus 20, it's good. Going to check the dielectric absorption first, and I'm doing that because you have to. It's best to do that before you do the leakage test, because the leakage test might store some voltage in there that will disturb the dielectric absorption test. So holding the button down, it's doing its thing, and it gives a reading of 5%. If you hold the button down, it will cycle through a couple of functions of the test as well. It'll continuously cycle through every 4 seconds or so. That one's staying solid at 5. Capacitor ESR. It's coming up with a negative reading, which means somehow or other it didn't lead 0 well. Let's check what the lead 0 is in the ESR. Usually when you lead 0, it nulls it out pretty good. Lead 0 is about a 0.5, 0.8. Try it again. It's funny how that happens. A little more realistic, we're holding about right at 0, which is, it was comparable to the dead lead short anyways. And leakage. And after a couple of cycles, it's giving a proper descending value, going down about 30 or 40% at every sample, which is pretty good. So there's no reason to believe that this particular capacitor, it's like I said, this is a Fuyin brand, and no reason to believe why that couldn't have stayed in service except for its age. If you see one in a device that, especially if it's 105 degrees C, apparently they make some pretty good capacitors. So, so we're going to compare that one to the brand new Worth that I have. Same values. You can see it's connected to the leads there. Gonna go value 4220, almost an identical capacitance. The dielectric absorption on the other one was 5. This one's 6. See if it lowers with another cycle. Nope, it's holding right at 6, so it's happy there. Capacitor ESR. As far as it's concerned, that capacitor is dead short, and then the capacitor leakage for the ESR. And this one, after the second cycle, it's behaving just like the original pull. It's going down about 30% per sample. Or maybe a little less, but still steadily trending downward, which is good. So, so the power supply is happy. It probably would have stayed happy for a while, but I just would have hated to have had a surprise with that old capacitor. So I think in all practicality, I I'd like to check the ripple current on these when it's in use with a load, but don't really see the reason to. That would be really get into microminutial capacitor testing for just a simple unregulated linear power supply. So I think I'll leave this at that. I'm going to install one of these guys, probably end up installing the CDE just for the package size. This one I'm going to save for another power supply that I'll have an upcoming video on. So that'll be it for this episode, and thank you for viewing. If you like the content, please feel free to give the video a like, and if you can subscribe to view more content as it comes up, feel free to hit the subscribe button as well. And thank you. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.